Hello, my name is Hannah Triber, and I will be presenting fire protection equipment and systems along with Alex Cowles, Colton Kauser, and Taylor Webb. In this presentation, my group and I are going to thoroughly explain the moving parts of fire protection equipment and systems. Before I begin, I have a couple of questions one might ask to help provide a better understanding of fire protection systems and what they are. What is a fire protection system? And the definition of this is a system that includes devices, wiring, piping, equipment, and controls to detect a fire or signs of smoke to create a signal and to suppress the fire and smoke. This will eliminate all signs of chaos in the event of an emergency, such as what to look for and what to do. What are the objectives to such systems? There are two. The primary objectives, most importantly, are to save lives and to prevent the destruction of property. And the secondary objectives are to minimize interruptions of service due to a fire or alert of a potential fire. For example, in a huge building, it may be difficult to evacuate in a timely manner. If the fire is small and easily controlled, it can be unnecessary to evacuate an entire building if only one section of this building is in danger. The next question is how much do fire protection systems cost? This is important to builders and construction managers that want to cut costs where they can, and a fire protection system is not one of them. These systems and certifications are required per the fire and building codes. The initial cost starts from 1% to 5% of the total building construction cost. This saves money in the long run because no one can turn back and sue construction managers or builders if fire protection systems are installed properly per the code. How do current trends affect building codes? For example, high-rises are very popular to conserve space in cities, but you wouldn't want to place a high-rise in a smaller town due to the size of the building. Every building must refer to local fire department capabilities. So in this case, it doesn't make sense to build a high rise in an unpopulated area because the fire department would most likely be small. It would be very hard for them to contain the fire of a high rise. Another way a current trend affects building codes is architectural design. The trend these days is modern lifestyles and decorations. Designing architecture this way implements open workspaces for better communication and productivity, but this is very dangerous because fire spreads very rapidly in open spaces, and the code requires firewalls and partitions to stop the spread of the fire. So that stops it from making it move so quickly. Next, we're going to talk about classifications of fire and construction hazards. These are things you should know just being an occupant of a building. The definition of fire is the rapid combustion of materials in the presence of oxygen. And there are two components to this: thermal, which is flame and heat, and non-thermal, which is smoke and toxic gases. Smoke is always associated with fire. Smoke is the primary cause of fire-related deaths. Therefore, these systems are not only designed and implemented to detect and eliminate fire, but detect and eliminate smoke as well. Next, we're going to break down the classification of fires, and this is important to know because it determines the type of fire protection systems installed. The NFPA, which is the National Fire Protection Agency, says there are 4 classes of fires, and this is important to know because it gives you the proper way of extinguish for each of these classes. Class A fires are ordinary combustible materials. For example, this includes wood, cloth, paper, rubber, and many plastics. Class B are flammable liquids, oils, greases, tars, oil-based paints, and some flammable gases. Class C fires are energized electrical equipment, and it's important that the extinguished medium does not conduct the fire. For example, water is a conductor for electrical equipment, electricity. So that would mean that it would not be a safe route to extinguish the fire with water in this case. You would want to find an extinguished medium that can actually put out this fire in a nice way. And we'll be talking about that later on in our presentation. Class D fires are combustible materials. or metals, I'm sorry. This includes magnesium, titanium, sodium, and lithium. Next, we're going to talk about the classification of hazards. And this is important to know because it determines the type of fire protection systems installed. The NFPA says fire hazards can be grouped into 3 different classes. And breaking those down, we're going to start with light hazards, which are low hazards. And these are locations where the amount of Class A combustible materials is minor. For example, this includes the furnishing and the decorations involved in these areas. And these locations are offices, classrooms, churches, assembly halls, and something along those lines. Moving on to ordinary hazard, which are moderate hazards. These are locations where Class A and Class B combustibles in total are greater than expected under light hazard occupancies. This can be further broken down into 2 groups. Group 1 is stockpiles lower than 8 feet, and Group 2 are stockpiles lower than 12 feet. These hazards can be found in such places such as mercantile shops, light manufacturing, auto shops, etc. And moving on to extra hazards, which are high hazards. These are locations where large quantities of highly combustible materials and conditions where fires could develop quickly with a very high heat release. And this one can also be broken down into 2 different groups. Group 1 are occupancies that have few or no flammable liquids. And Group 2 are significant amounts of flammable liquids or locations where combustibles are shielded from suppression. Therefore, fire protection systems must be designed specifically to be the most effective for each class of fire and each class of fire hazard. Now we're going to talk about the type of construction. So per the building code, building construction is divided into type 1 through type 5. We are going to focus on type 1 because it is the most fire resistant, therefore the most ideal to use along with fire protection systems. This includes walls, partitions, ceilings, floors, structural systems, and exit envelopes. All of these should be constructed of non-combustible materials such as brick, concrete, metal, steel, sheet glass. These materials must have at least the minimum fire resistant rating per the fire code. Now, it's very important to talk about planning for a fire protection system. And this starts with the architects and the engineers. Once a plan is constructed and implemented by the architects and engineers, a well-planned fire protection system usually operates as follows. Step 1 is detection, which is the noticing of fire and smoke. This can be detected manually or automatically. Step 2 is signaling. The building's management, occupants, and the fire department are notified of the fire. The occupants are then advised on which actions to take, whether this be to stay put or to evacuate the building. Step 3 is suppression. This can be manual or automatic fire suppression equipment and systems, and these are used to extinguish the fire and to remove the smoke. And moving on from suppression, there's 3 different efforts that are given to suppress a fire. Initial effort are portable and manual fire equipment. This includes fire extinguishers, fans, first aid hoses, and these are used to extinguish the fire and to remove the smoke by dilution or exhaustion. Next is the main effort. Fire suppression systems such as automatic sprinklers, fire hoses. These are used to extinguish a fire, and smoke control systems are activated to remove or eliminate the spread of smoke. The last effort is the fire department takes over the firefighting effort when all previous efforts are ineffective. And it's very important to note that a fire may spread rapidly within minutes. And all 3 steps of fire protection may have to be initiated or activated concurrently to prevent it from spreading. The presentation will now continue with more details on fire protection systems and how they work.
Hello, my name is Taylor Webb, and I will be doing fire safety design. Fire safety design takes into account the building's use, occupancy, layout, and other systems used in order to build a safe space for people to work. Fire safety design has become more and more popular as more material design and technology have come around. Fire-resistant construction uses materials such as fire-resistant gypsum board, fire retardant sheathing, and chemicals to coat materials to help resist fire. Fire-resistant materials take longer to catch fire and may spread slower. Materials are given fire-resistant ratings, which informs how long a component is able to confine a fire or can continue to perform given structural functions. A 3 to 4 hour rating is considered average. Smoke controls. Smoke controls is the ability for a building to remove, dilute, and or confine smoke using anything from a complicated mechanical system to simply opening a window. Mechanical systems can increase or decrease pressure to certain areas to help control smoke. The length of travel, the distance from any point or building to the nearest exit is what that is. The length of travel needs to be within the accepted distance provided by the building's fire code. The accepted distance may increase when more fire safety systems are in place, such as sprinklers and or smoke alarms. Means of egress. Means of egress means escape route or exit. In most buildings or large rooms, there should be at least 2 means of egress. If the space is small enough and it's concluded that a second opening or exit would only increase safety minimally, then there's only one exit. Is it okay? Exit enclosures are safety exits that are enclosed usually inside of a building, such as a stairwell. They're usually made of highly resistant material, which allows for safe escapes during fire. Ducts, conduits, and pipes should not enter or be housed in exit enclosures, since these things can make it easier for fire to spread into these areas. Adequate lighting has to do with whenever there is a fire, there's enough light into these safe escape areas for people to see and get out safely. Clear signs that point the way out on average are safe, like exit signs are usually on average 7 feet high to allow for visibility. Additional lighting at 2 feet above the floor will increase safety in smoky conditions. Vertical openings should be sealed with caulk when optimal, or fire shutters that help seal the area and keep smoke and some fire out. Joints such as where the floor meets the wall should also be sealed to prevent airflow between different levels. The less air that can flow between rooms and buildings and levels, the slower the fire will spread. Vertical transportation needs its own fire protection to ensure safety for people trying to exit. Fire shutters can help prevent the fire from spreading and a little bit of smoke from spreading. Elevators are still not seen as a safe way to escape a fire, but research is going into fireproofing elevators so people who are disabled are able to escape easier. Elevator shafts or vertical openings may be pressurized or ventilated to prevent the fire or smoke from spreading. Coordination with mechanical and electrical. It is important that mechanical and electrical systems work together to alert and prevent the spread of fire. Electrical systems such as alarms need to tell the mechanical systems such as HVAC or sprinklers that there is a fire, so that the HVAC systems and sprinklers can ventilate or put out the fire in those areas. Compliance with code. Every building must follow the fire code set in its area by the National Fire Protection Association. A building's fire code requirements are based on the use group, area, occupancy, height, and other factors relating to life safety. The authority having jurisdiction, or AHJ, will determine what fire codes you must follow. An AHJ member can be a fire marshal, a building official, or the fire department, and sometimes all three. Coordination with the fire department. The AHJ, such as a fire marshal, must be consulted about the required access to the building and location of fire hoses, fire hydrants, electrical power disconnects, and fire suppression alarm systems.
Good afternoon, everyone. My name is Alex Cowles, and today I'm going to be going over components of a fire alarm system. Within a fire alarm system, you're going to have 3 main components. You're going to have thermal detectors, smoke detectors, and signaling devices. And today with me, I'm going to go over the details of these, benefits, applications, and some disadvantages, and just overall in detail on what they are and what they do. So moving on to the first one. We are going to go over, first one we're going to go over is a fixed temperature thermal detector. So what this thermal detector is, it's a device that detects heat, not smoke. So within this diagram, you can see On the far left is normal conditions, middle one during a fire, and the far right during a fire too. So just kind of describe what it does is inside this thermal detector, you have a bimetal material that is very, very heat conductive and reactive to heat. Once it heats up, it bends, as you can see in the last diagram. Heat is collected through this into this thermal detector through air vents, which is brought into the heat collector, which transfers the heat to the bimetal material. Whenever there's a fire or a potential fire and the heat raises to the thermal detector, the material will bend and it will actually push. On the far right, you can see it pushes up the two contacts together to complete a circuit, letting you know, hey, there's a fire in this room or building. Action needs to be taken. It sends a signal to the monitoring device, whether it's a computer company that has live people watching it. Super cool how these things work. Moving on to some of the benefits of these things. Some of the benefits is they are more accurate at detecting a fire than a smoke detector. Another one of the benefits is they're not affected by dust, which is super cool, and they're actually a lower cost than a smoke detector. Some of the disadvantages of these, though, is that they do take a little bit longer to detect a potential fire within a building. Another one of the disadvantages is this thermal detector is strictly used for property protection. They're slow at detecting a fire, but they're more accurate, slow but more accurate. Not going to be the best for a building that's densely populated. As far as application goes, because they're not affected by dust, you're going to want to put these in like your warehouses without any people, like storage buildings, laundry rooms, garages, anywhere that's more prone to have dust collection on surfaces and whatnot, and dust kicked up. Moving on to the second type of thermal detector, you have what's called a rate of rise thermal detector. Both these thermal detectors, they can be programmed to trip the sensor at a specific temperature. The process of how this rate of rise thermal detector sends a signal is a little bit different, but the principle is still the same. As you can see, you have an air chamber. Within this air chamber, there's obviously air. And whenever there's a fire, the heat rises and it expands the air inside of this chamber. When the air expands inside of this chamber, it actually pushes the diaphragm, which is the top part of that air chamber. It pushes it up and causes it to bend, almost bubble up. And when it does that, it pushes the two contacts together, completing the circuit, sending the signal again to the monitoring system, whether it's a computer system, live person watching it, and or the fire department, letting you know, hey, we got a fire, action needs to be taken. Moving on, some of the benefits of these rate of rises is these are faster at detecting a fire than your fixed temperature thermal detector. Just like the other ones, they're not affected by dust, and they are more accurate at detecting a fire. Some of the disadvantages, though, is that they are slower at detecting a fire, so they're going to be strictly for property protection only, and you're not going to want to use these things you're not going to use these as your primary source of fire detection where you have a bunch of people at. Application is pretty much the same. Your dusty areas, garages, storage buildings, warehouses, laundry rooms, anywhere where there's a lot of dust in the air that won't affect the thermal detector. Moving on into smoke detectors. What is a smoke detector? We've heard of smoke detectors all of our lives, ever since we were young up until today. You think a smoke detector. What is a smoke detector? Well, I'm going to be straightforward with you. It's exactly what the name says it is. It's a device that detects smoke. And what different types are there? As far as we're concerned, there's two main types that are used in construction. Two main popular ones that you'll see day in, day out. Wherever you're at right now, if you're inside of a building, more than likely you have a smoke detector within 10 to 20 feet from you. I promise you or a thermal detector. You have some kind of fire detection device not far from you. I promise if you're inside, you have one close, or at least you should. Moving on. So to the first one is a photoelectric smoke detector. As you can see here in the diagram, you have a LED diode that sends a light beam inside of the smoke detector. And at the bottom of that smoke detector, you have a photoelectric light sensor that is reactive to that very specific LED diode's light rays. So if there's whenever there's a potential fire, smoke goes inside of the smoke detector, and as you can see in the diagram, it bends the light rays. Light refracts and it bends whenever it comes into smoke. Kind of like whenever you're driving on a foggy day. You're driving and it's super scattered. You can't see very far. It's because your headlights are dissipating all the light all around you instead of just punching through. The smoke or fog in that situation just bends the light rays in all kinds of directions. Same with the smoke detector. Smoke enters it, bends the lights. They hit the photoelectric sensor, completing the circuit, sending a signal. Hey, we have a fire. Take action. Benefits of these things is they are faster. They are faster at detecting a potential fire than both of your thermal detectors. The biggest benefit of these things is because they are so fast at detecting potential fires is they are the best for protecting human life as far as alerting people that there's potential fire in the building. Disadvantages is they are more expensive. They are more expensive than your thermal detectors, and they are affected by dust. So, if you have one of these in a super dusty area and someone walks by or sweeping and kicks dust up in the air, it could potentially trip that smoke detector and, send a false alarm. You could have a lot of false alarms if you have these in the wrong places. Applications, you're going to want to keep these things in a pretty dust-free area, but the main thing is you want to have these where human life is. So residential homes, your bedrooms, your living rooms, your kitchens. The main place in homes where people spend the majority of your time is the bedroom and the living rooms. So you're going to have these inside of your homes. As far as commercial goes, hotels, schools, hospitals, office buildings, basically wherever you have a large conjugation or a large percentage, of human life. You're going to have a photoelectric smoke detector in there. Moving on to the second type is an ionization smoke detector. As you can see here in the diagram, you're going to have two metal plates or two charged plates that have charged particles that go in between, that travel between the two of them. Depending on the type, it actually could contain a small amount of radioactive material. And what happens is whenever smoke enters this smoke detector, it actually ionizes it and completes a circuit. When that circuit is completed, the signal is sent to the monitoring device, letting them know that, hey, we have a fire in this room or a potential fire. Action needs to be taken. Benefits of these things is they are fast. They're fast at detecting a potential fire. These are also the best for detecting what's called a flaming fire, which is a fast burning fire. So residential homes are considered a fast burning fire. So not only photoelectric smoke detectors will be in your home, but you're also going to have, potentially you can have both or one or the other. You'll at least have one ionization type smoke detector in your home upon new construction, just because they're the best at detecting a flaming fire, which is, your homes, residential fires are considered flaming fires, fast burning, just because they're all made up of 2x4s, plywood, drywall, your wooden cabinets, a lot of stuff that's very, very fast burning. The disadvantage of these is they are affected by dust, just like photoelectric, and they are more expensive than your thermal detectors. Application is going to be pretty much the same. You're going to have these installed where you have, human life, schools, hotels, homes, office buildings, you name it, wherever there's people and they're staying, you're gonna have a smoke detector there. Moving on to signaling devices. So I'm not going to go too much into detail on signaling devices and every single action that they do, but here are a few examples that you can see here. My personal favorite out of this list is the ceiling mount speaker strobe. So go, as the word says, as the name of it says, it mounts on the ceiling and has a strobing light. But what's cool is that speaker inside of the inside of the signaling device is actually able to be controlled by a microphone. So you can have someone in an office or someone monitoring let's just say you have a fire in a building and you have someone monitoring, you have the monitoring system on the line through the PA system on that smoke detector or signaling device. I'm sorry. Let's just say exit B is blocked. They can actually go through that signaling device on the speaker and be like, hey, attention everyone, exit B is blocked by the fire. Please transition over to exit A or exit C, etc. Just letting them know, where the fire is the worst and where to go. One that you've probably seen pretty often grow, if you went to public school, is the weatherproof horn strobe and the ceiling horn strobes. The weatherproof one is cool. Whenever you're on the outside of a building, you'll still be able to hear the alarm just because those are on the outside that can handle rain, wind, hurricanes, and now here in Texas we have Texas blizzards, so they're able to withstand all of that. Moving on to fire alarm system costs. So as far as new residential construction goes, you're going to be anywhere from $2 to $3 a square foot. The average cost is between $650 to $950 for a fire alarm system in a brand new home. As far as existing residential construction goes, it's a little bit more expensive. It's anywhere from $4 to $12 a square foot. A little bit more of a gap in that price range because you have so many different year gaps of existing homes out there. You have some homes that were built 10 years ago. You have some homes that are still standing that were built 60 years ago. The amount of retrofitting to get a brand new fire alarm system installed is what's going to drive that price up and up and up. So there's a little bit more play in there. But moving on from there, we're going to go into commercial construction cost. So in my research, I was not able to find an average cost for a fire alarm system within like a commercial aspect, just because there's so many different factors that go into it. There's three main factors that through my research I was able to come up with. First one is building size and complexity. So you have skyrise or skyscraper buildings, in downtown Houston that are hundreds of feet tall. The fire alarm system that takes place for one of those buildings is going to be astronomically more expensive compared to like a 3,000 square foot, office building here in the Conroe or the Woodlands. And then you have type of equipment. So you have a lab that's built. You have a science lab. They're going to have the state-of-the-art, top-notch equipment that's going to be able to detect every single fire under the sun. Though they're going to be spending all the money they can on the best fire alarm system to make to stay on top and protect all their equipment, compared to like a storage building. Out in Kentucky, they have hundreds and hundreds of buildings, so just their storage buildings that are used to store, barrels of bourbon. Their fire alarm system or detection system is not going to be anywhere near as expensive as like a skyscraper building. And then of course you have monthly monitoring fees, depending on if a building even has a monthly monitoring fee, or they just have or if they just have the devices installed in the ceiling and they have no one monitoring it, just to lets the alarm know, like, hey, people in this building, alarm's going off, get out. Skyrise buildings, skyscraper buildings, with people in office buildings, they're probably going to have a monthly monitoring fee. Same with your science lab. Hey, this sector here, fired thermal detector A over in, floor 1 and section A of the building is 10 degrees hotter than, on the other side of the building. It's going to be very in depth on what they can detect. So that's just kind of like the main factors that are going to drive the different prices. That's really hard to find an average. But moving on, this is just, a PDF scan of a print. I do apologize if it's not so clear, just kind of blowing it up to where we can see it on the PowerPoint. It's going to lose a little bit of the quality, but you can see here just all the green and red, the amount of detail that goes into, placement. These are all designed by, fire detection engineers or fire engineers. And then the next one, you can see how it's drawn up in AutoCAD. Very complex, a lot of design, a lot of planning goes into these, where you're going to have signaling devices, what kind of detection device do you want, where to put them, what time, there's a lot that goes into it. And that is the end of my section. So thank you so much. Hope you have.
My name is Colton Kauser, and I'll be covering the fire suppression systems. You know, we've talked about fire alarm systems, types of fires, the way to build buildings to prevent the spread of fires. So now we're going to talk about the fire suppression systems. So what is a fire suppression system? A fire suppression system is an engineered group of units that are built to extinguish fires through their applications. And these applications vary depending on what kind of fires there are between Class A, Class B, Class C, and Class D, which Hannah touched on. So, and then what I think is very important that we want to cover is which suppression system is best for each class of fire. And these suppression systems detect through heat, smoke, or other signals that Alex covered on that immediately engage the suppression system, as you can see in the bottom right with this photo. There are systems and extinguishers, and then as you can see, there's a combination of both in this photo right here. And so that's what I will be covering today. So it's important to know that the fire triangle. The fire triangle it takes all three of these: oxygen, heat, and fuel to keep a fire going. And so it's important to know which extinguisher or which application of system is used to prevent further damage or take out the fire as quickly as possible to prevent further injury, which is, we all know, of course, life is the most important part. So as you can see on the right here, it says know your fire extinguisher color codes. And so, as you all know, it's pretty much by code to have a fire extinguisher in each kind of house, even residential house. So if it's red, it's water, blue, it's dry powder, black is carbon dioxide, and kind of like no color, it just has the AFFF foam spray, and then there's a fire blanket, and then wet chemical. And as you can see, it mentions the class A, B, and C, and D, and whether or not it'll be able to cover that or not in this slide as well. But I'll be going into further depth throughout the slides. So water is only good for class A, dry powder is good for all of them pretty much. And then carbon dioxide is good for B and C. And then, foam's good for AB, so on and so forth. So for class A fires, which is pretty much the most common fire, which is like wood, textiles, cloth, and things like that, things that happen all the time in your house. And so what the fire suppression system that we're going to use here is a water system and a water foam fire extinguisher. So we have a combination between an extinguisher and a system in this slide. And the biggest thing that the water systems and water and foam fire extinguishers do is that it takes away the heat element of the fire triangle. So as you know, you need to have all three of them to keep the chemical reaction going. So these extinguishers and suppression systems take away the heat. And then the foam also takes away the heat. So if we're using water, it takes away the heat, and then the foam takes away the heat as well. Water extinguishers shouldn't be used in class B or C fires because it can cause more harm than good. It can spread the fire or create even more shock hazard in class C because class C is actually an electrical fire. So it's very important to understand what kind of fire you're dealing with and then what kind of suppression system or extinguisher to use. And that's what I think is really important, and that's the kind of message that I'm trying to get across. Class B and C fires. So for class B and C fires, you're going to want to use a carbon dioxide system and extinguishers. So again, you can kind of see in this right photo right here. This is more of a system, but you're going to have to imagine there's a wall between all these canisters, and then it connects throughout the roof. And on the left is just your typical carbon dioxide extinguisher. And this handles your class B and C fires. it takes away the oxygen element, also removing the heat. So this one actually knocks out two of the fire triangle elements that keep the chemical reaction going, keep the fire going. So it's very beneficial. And so these are the ones that they'll handle your gasoline fires, your electrical fires, things that you wouldn't be wanting to use water on, because, you know, I don't know how many of y'all have ever tried to use water on a grease fire in your kitchen, but it doesn't really work too well. So that's why it's really important to understand that what your chemicals that you're dealing with and what chemicals you want to use to put out a fire. So again, we're going to use chemical clean agent fire extinguishers and suppression systems to get rid of class B and C. You know, it's very similar to carbon dioxide, but the chemical clean agent fire extinguishers include halo agents along with less ozone depleting halocarbon agents. So what this does is it's a little bit more advanced. So it's going to want to use a little bit more science behind it, and it kind of drains the fire completely. It stops the chemical reaction of the fire. And again, you can have these in extinguishers and in the fire suppression systems. And most of these fire suppression systems, they want to, you know, they're immediately detected and automatically distributed throughout the building that there's a fire in. So that's why it's really important, you know, what Alex covered with the fire alarms and stuff like that. You know, there's handheld ones, and then there's also the ones that you see in your roof and stuff. So it's really important to have all these work as a cohesive unit, because of course, the quicker you can put out a fire, the less damage, and therefore you're going to be saving lives. And here's kind of the, you know, all around it covers a lot of them besides the combustible metals. So class A, B, and C fires, it's a dry chemical fire extinguisher. This one's in a lot of your houses because it is so broad and it can cover a lot of different kinds of fires. So what this does in the fire triangle is it interrupts the chemical reaction, and by doing this, it really decreases the spread of the fire, again, preventing further damage. So as you can see in the bottom right, we have a little bit of the features that are brought up in dry chemical fire extinguishers. And then in the left is also another picture of a fire suppression system that is connected throughout the whole house. This is the most widely used extinguisher system. With the class A fire, it creates a barrier between the oxygen element and the fuel, therefore slowing down the chemical reaction as well. And now we're going to get into the class D fire extinguisher and systems. This one is kind of tricky because it's combustible metals, and so you see these in factories that deal with a lot of metals, and so these fires are really dangerous because they will just keep spreading and spreading and spreading until you use the proper suppression systems. And these suppression systems are dry powder extinguishers. And what this does to the fire triangle is it separates the fuel from oxygen element by removing the heat element. So it really knocks it out pretty quick because the metals get really hot. So you want to have that dry powder to kind of put like a blanket over it. And these dry powder extinguishers only work on class D or combustible metals, because if you try to use these with any other type of, I guess you could say, fires, then you're gonna have a lot of trouble putting it out, and it's gonna be tricky to prevent losing lives because you don't really understand what kind of fire you have and what kind of suppression system to use. So that's it for fire suppression systems. I hope that you have a little bit better understanding on what it takes to put out a fire and what kind of fire extinguishers to use or fire suppression systems to use, depending on what kind of class fire it was.
Hello, now I'll be talking about smoke controls. With fire comes smoke, which can be just as dangerous. Smoke can spread faster and further than fire and is able to reach areas that fire cannot. The amount and type of smoke depends on materials burned. Wood and paper burn into less dense and white smoke, while plastics and synthetics materials create heavy black smoke that is toxic to breathe. Stack effect is important when thinking about designing a building. It is the movement of air due to different air temperatures inside and outside the building. Cold outside air will tend to move upwards in a building due to the less dense warm air inside the building and vice versa. Stack effect is important in places such as elevator shafts because air will quickly move between levels and can get smoke into those different levels. HVAC will counteract the pressure differences and limit air movement between floors due to stack effect. Air will flow between pressure controls. Air will flow between two areas of different pressure from high pressure to low pressure. By taking away pressure in a fire can be better contained to an area. Local exhaust works by ventilating an area close to the fire, which brings in air, preventing smoke from spreading to different areas. Vent hoods are a common example of local exhaust. A pressure sandwich works by increasing the pressure around the fire, which causes the fire to be the low pressure area, preventing smoke from leaving. It works by ventilating fire area and pressurizing adjacent areas. Compartmentalization works by breaking a building into 3 sections. Each is sealed off from the next floor. There we go. Having each section separate makes it difficult for smoke to spread between areas. It can be costly to build since each area needs its own duct, stairwell, piping, etc. Usually only used in buildings over 50 stories. Stair pressurization uses a high pressure system to keep smoke out. By keeping the stairway at higher pressure, the rest of the building is at a lower pressure, keeping the smoke out of the stairwell so people can safely exit. When thinking about stair pressurization, you must keep into account the pressurization on the doors. 30 pounds is the average that a person can push against the door and be able to open it. Pressurization must be able to be handled by multiple doors being open, so you need to have a good HVAC system. You also must have multiple points of air supply to keep the pressure even across the stairway, or else you'll create different pressure zones, allowing for smoke to move through the stairwell. By sealing all penetrations, openings such as pipes, ducts, and structural members need to be sealed to prevent smoke from moving through. Ducts should be interlocked with fire and smoke dampeners.